In today's webcast, we talk about how Merck Millipore's Chromolith columns are ideal for the analysis of food samples with complex matrices, samples which are often simply referred. Most HPLC methods use particle-packed columns, and particles by their very nature give low permeability and high back pressure. Dirty samples block or plug particle columns easily. By contrast, Chromolith monolithic silica columns are made of a single piece of porous silica with a bimodal pore structure of macro and mesopores. Chromolith columns have large macropores and resist plugging or blocking even with dirty samples. The mesopores give the high surface area and the excellent separations. The large macropores of Chromolith columns are also the key to the very low column back pressure and give many more advantages as shown here. Today we will focus on the advantages for the analysis of food samples. To demonstrate the scope of Chromolith columns in food safety testing and quality control, we have published a new application compilation with 76 pages and 17 applications, including carbohydrates, vitamins, pesticides, food additives, and colorants. The analysis of bisphenol A in milk powder is one good example demonstrating how Chromolith columns are ideal for complex and dirty samples. In addition, the compilation also includes 10 pages with important information on food safety regulations in Europe and in the United States. Today we have selected 3 examples from this compilation to illustrate the robustness and speed of analysis with Chromolith columns. In our first example, we show a method for the analysis of 2 food colorants, Amaranth and Allura Red. This method illustrates the long-term performance and robustness of monolithic silica columns. More than 8,000 samples were analyzed on a 50 by 2 mm RP-18 end-capped Chromolith column. The sample was an Alcopop alcoholic drink which has a complex matrix, typical for many beverages. The only sample preparation done was filtration using a 0.45 micron Milex filter. High-resolution separation was achieved in less than 4 minutes. The graphs shown here illustrate how column back pressure, retention time, peak symmetry, and peak resolution vary according to the number of samples run. In total, 8,300 samples were analyzed. The largest effects are seen on peak symmetry and column back pressure. The column back pressure increases with time as sample matrix accumulates on the column, but never exceeds 100 bar or 1450 psi. Peak symmetry is almost constant over the first 4,000 injections, after which a slight deterioration is observed. Despite aging of the column, peak integration and the accuracy of quantitation were unaffected. In food and beverage testing, there is a great demand for rapid, simple, inexpensive yet robust methods, not only with UV detectors but also with mass spectrometer detection. In the example shown here, 2 colorants in yogurt were separated in less than 5 minutes using a short 50 by 2 mm Chromolith column. The first detector is a UV detector for quantitation, followed by a mass spectrometer for confirmation of peak identity and purity. In the next example, we show how a monolithic capillary column was used for the fast determination of pesticides in porcine kidney using an LC-MS method. A sample of porcine kidney was spiked with 6 pesticides. With the Chromolith Caprod RP-18 end-capped column, all 6 pesticides could be separated in under 7 minutes. The fourth method we show was developed by a customer at Cerveceria Polar, a brewery in Venezuela, for the analysis of iso-alpha acids in beer. Originally, they had used a method with a particulate column. The extensive sample preparation required was time-consuming and costly. In addition, the column lifetime was short. Then they transferred the method to a Chromolith column. As you see in the chromatograms, each analysis now only takes 6 minutes instead of 16 minutes previously. The only sample preparation step now required is sample filtration, and the column lifetime is more than doubled. The customer calculated the benefits of using the Chromolith method, both in terms of cost and time savings. They demonstrated they were able to save 60% of the cost per analysis, and the time savings per analysis was 86%. The time savings were achieved not only by simplifying the sample preparation, but also by the significant reduction in analysis time using the Chromolith column. All the methods we have shown so far use RP-18 reversed phase columns. However, in the application Compilation, many different Chromolith columns have been used. Bonded phases now include RP-18, RP-8, nitrile, amino, and diol. It's possible to say there is a Chromolith column for every occasion. To summarize, Chromolith columns are a great solution for the analysis of dirty and complex samples in food applications. The examples shown in this webcast demonstrate that Chromolith columns offer a quick, easy, and reliable solution for food safety and quality control analyses. Methods are robust and fast, and frequently require only minimal sample preparation. If you would like to receive your own copy of the complete application compilation for food safety and quality control, please use the link shown here on this slide. Or if you would like to know more about Chromolith columns and their applications generally, please send us an email to chromatography@merckgroup.com. Thank you for your interest.